So for example, in general, if I had just something times who cares something else, that's not going to be pretty, is it? Let's make this like this. Let's make this like this so I can make a nice point. Square root of 3 times square root of 3 is
9.
Square root of 9, which is 3. Plus 5 minus 7, so minus 2 of these. We'll do this a little quickly. 5 times negative 7 is? So that is it. That's rational. That's rational. The only place it could still be irrational is in the middle. Do you guys see that? So if I make the middle term disappear, there won't be any radicals left, and that's the only place they could possibly show up. That's why this method works. Because I make the middle terms go away. How do I do that? Difference of squares kind of idea. Right? In this context, we call it the conjugate. We multiply with the conjugate, but you can also think of it like the difference of squares buddy. Or whatever the hell you want to look at. So how would I do this? What would that guy's conjugate be?
Minus 3 times square root of 2 minus 7.
Yeah, 3 rad 2 minus 7. So if there's more than one term, I have to somehow take care of everything at once. So I have to multiply this by 3 rad 2 minus 7. Ooh, that's almost it. Poor little dude. So on the top I get, what do we get on the top? 15 rad 2
Minus 7 is 35.
minus 35. I'm going to multiply that by 5 over
9 rad 2
9 rad
minus
9 rad
Oh, right.
4
7.
plus 21 of these minus 21 of these. I designed it so the middle term would cancel, right? I designed it so that would happen, so I shouldn't be surprised when it happens. So middle term cancels.
49.
Minus 49.
Which is 7.
No. No radical in there. So on the top I get 15 rad 2 minus 35. No like terms up there, so oh well. On the bottom, what's 9? What's square root of 4? 9 times 2? 18 minus 49?
Minus
31.
Negative 30. All right.
Yeah.
And you could take the negative up, but screw that, it's just extra. But did I make the bottom have no radicals anymore? That's the whole point of rationalizing the denominator. Make the bottom non-radical. So when there's more than one term in the bottom, you need extra help. That's why I got to use this guy. A little extra help.
How did you get that again? Just the bottom part? I'm sorry.
Square root of 4 is
2.
2. 9 times 2 is
18.
18 minus 49 is negative 30. So just cleaning up the bottom.
No problem. So you don't clean up the top. Like, say if the top could be cleaned up, would you clean it up?
Of course you would, yeah.
But if there's no square, I mean,
Yeah.
square, I mean, it pretty much stays
Watch
the
this.
same.
So here's a problem like what you're saying. So if I had on top, I like it. That's yummy.
So you're just going to multiply the top by the opposite of the bottom?
Well, you got to multiply
The
top and
bottom
bottom. Yeah.
by the opposite of the bottom?
Yeah, exactly. Well, almost sort of. The conjugate of the bottom, not the opposite of the bottom. Just make sure everybody's on the right track. What are you multiplying by?
7 rad 3 minus 2.
Square root of 2.
Rad 2, yeah. Sorry.
And now you just foil. Foil the top, foil the bottom, right? The top, the middle terms aren't going to cancel. So you got to get, wow, yeah, you are.
2 times 7 is 14. So it's like 14 radical 3. Yep.
Keep going.
Minus 2. And it's minus 2 radical 2.
Yeah, but keep it to yourself for a minute. Sorry, Rob. It's all right.
I'm so lost on this anyway. So.
Sounds like you're fine. Keep going. top. 14 rad 3, minus 2 rad 2, minus 21 rad 15, right? Plus 3 rad 10. So that's what you get on the top. How are we doing with that?
Wait. Why would it be 3 plus 3 rad 10? Like, why is it a plus?
Negative
Okay,
times
this
negative.
is a negative.
Yeah.
I wrote positive on mine. Okay.
That's crazy.
It is.
Now the bottom, what do you hear?
49 rad 3.
49 rad 9,
Oh, no.
Minus 7.
Minus-
Rad 4.
7 rad 6,
Yeah.
plus 7 rad 6, right?
So the count.
Yes. What's up?
Plus,
49 times 3 plus
Sure, so minus 7 rad 6, I'll write it out. Minus 7
Yeah.
rad 6 plus 7 rad 6. So those cancel.
oh, okay, yeah, count.
Middle of the bottom is always going to cancel when you use a conjugate. That's what you created to do. See how there's a radical there? So we can't let that happen. So I created something so that it cancels itself off. Kill itself off. And at the end I get minus
4.
minus 2.
No.
rad 4, which
Yeah.
is 2. I like it. So I get
49 times
the
3.
top is still 14 rad 3, minus 2 rad 2, minus 21 rad 15, minus 5 rad 10, over 49 times
147.
3, 147, minus 2, 140. When you do these conjugates, the bottom should always become a number, some kind of number. So read with me. 49 times 3
Okay.
Yep.
is 147, minus 2 is 140. Real quick, 49 times 3, 50 times 3 is 150. But I don't have 50 threes, I have 49 threes. I have 1 less 3, minus 3 is 147. And some of you are I'm just plugging a calculator. We're the humans here. We should know more than what we create. That's all I have to say. All right, let's do this. A little bit of time I got left. Well, I'll tell you what. I'm gonna do a little bit in the next section, and the first thing we'll do after the quiz tomorrow is this little group work thing, right? Because we're coming up on the end here, or my newly defined end of the class anyway.
So we're moving to 10.6.
Yeah, we're crazy like that. Oh my God. Again, it's almost like we're in a compressed course. All right. That was all 10-4, right? That was all 10-4. We don't do 10-5. Right, just because 10-5, yeah. 10-6 is the important thing. 10-7, by the way, is complex numbers, finally. Finally, complex numbers. 10-6 is important because one big thing about algebra is learning how to solve any equation that's thrown at you. And we haven't talked about how to solve equations that have radicals in them, right? So any function that we learn can show up in an equation. So what do you think I do? In fact, what's the main idea behind equations in general? Is if I see x over 4 equals 7, what would I do?
Find x.
Yeah, whatever operation I see happening to what I want by itself, I'm going to do the opposite. Right? So the whole idea of equations is basically knowing the opposite operation and then applying it. Does that make sense? That's equations, basically, just undoing what's there. Multiply 4, blah, blah. So x equals 20. That's amazing. So the interesting is, what if I had square root of x equals 6?
It'll be 36.
True, but what do you do to both sides? What's the opposite of square rooting?
Square.
Squaring. So I would square both sides for the exact same reason we multiply this by 4, because it's the opposite of what's being done to my poor little variable dude. So here it's being square rooted. I'm going to do the opposite so I can kill that square root. Set my variable free, right? So I got to square both sides. You guys understand what I'm trying to say here? Solving equations is all about doing the opposite of what's currently being done. So if I know the opposite of the function, I can do that. So I get x equals 36. And of course, if I just said to you, what do I take the square root of to get 6? You would say 36. All right. So when the problems get a little more disgusting, so you can't just figure them out in your head quick, you do the same thing. So what if I had the square root of 4x minus 2 equals 3? Square everything, right?
Get rid of the root.
To get rid of the radical.
And then solve.
You're knocking this wall down, it's stuck in the building, you knock the building up squared. Bam! Those
And then
cancel.
solve.
So then you get,
4x minus 2, 9.
let me stop there for a second, you guys with me?
Wait, what did you cancel?
The square and the square root, because they're opposites of each other.
Oh.
So I square both sides, so the square root cancels with the square.
Okay, so then,
What's the matter? How we doing? We're not doing well?
No.
so the whole equation
What's
is
the matter?
just
All
a
right.
sign, right?
I
Just the whole.
So this
focus
would
on
be,
anything.
it's too bad. So here. All right, let me explain it algebraically.
Sounds going over your phone.
Really?
I don't know, it's just a battery thing.
Oh, poor little
Oh,
dude.
the most important one.
Poor little thing. Forgot my life support. So, how do I say this? Okay, what is that?
7.
Let me make sure everybody, is that right? What is that?
Yeah, it's
49?
Well, it's not 49. It's,
It's just 7.
yeah, so there's a lot of different ways you can look at this.
Nice.
It's square root of 49, which is 7. So what did the square and the square root do to each other?
Cancel each other out.
Cancel each other. Why? Because they're opposites of each other. They are what's called inverse functions, if you want to get technical about it, but that just means, it's a fancy way of saying they're opposites. They kill each other. It's the exact same thing as multiplication and division are opposites of each other. Squares and square roots are the opposites. So if I had a cube root, what's the opposite of a cube root? What do you think is the opposite of a cube root? A third power, right? What's the opposite of a square root? Second power. What's the opposite of a cube root? Third power. Bam. Why? And I really want you. How do I rewrite cube root of 7? Just the inside there. How do I rewrite cube root of 7? 7 to the 1/3. So what do these do? Don't they kill each other? There. So roots are the opposite of their associated powers.
Those multiply, right?
Totally.
So 1/3 of the
Totally. That's why they kill each other. So these kill each other. So if I see a radical in an equation, I can apply its power to kill it. It's the opposite of it, right? So, let's do another. So if I have the cube root of 7 minus 2x equals 2. And again, it gets down to the point where I want to be able to subtract 7 and I want to be able to get my x by itself, but it's currently, where's this? It's stuck inside of this stupid thing. So I can kill that stupid thing, then I can start moving shit around, right? So how do I kill the cube root?
Cube it.
Cube it! If I cube that side, I better
Cube
cube
it.
that side. Come through. So what happens here?
Gets rid of it.
You get 7 minus 2x. It really sucks when people have a third power there still and they multiply. Oh my god. That third power died. Right? Don't do that to yourself. And then people are like, you made a long test. No, I didn't. You did some weird shit. What do you got on that side?
12.
2?
2 times 8.
8. That's right. Just throw another 3 in there, but no.
negative 1 half.
Yeah, subtract 7, negative 2x equals 1, and then 2 times negative 2x equals negative 1. Cool. Alright, how we doing? Alright, now watch. Now, do square roots have any problems? Are there certain things it can't handle? Square roots?
Yes, negatives.
Can't handle negatives, right? I like it. So it can't have a negative inside, and it can't
Prime.
have a negative as an output, right? You guys kind of with me? So in general, now cube roots, of course, are cool. They're fine with negatives, aren't they? Totally fine with negatives. So I can't, let me see. if I solve this equation, I don't know where I am with this shit, so let's just start with A. If I solve this problem, what can I immediately do?
No solution.
No solution. Just like this. They both are no solution, because absolute value can't be negative, square root can't be negative. No solution. Kick ass, how are we doing? Okay. So, now, let's do one more simple one.
Just a question, when you're doing the square root, like you have inside there, what happens if you have, I don't know, if you just have the square root over part of it, what's inside there?
Oh, okay, we're getting there.
Oh.
Is that the next thing I want to do? Yes, sure. So remind me, when I had this, and some of you guys need to remind yourselves, what would I do first here?
Get rid of the one.
I have to isolate my absolute value, right? So what if I had this equation?
Same thing.
Isolate the,
Because if you try to square right now, you have to square this side, you have to write it twice, you have to FOIL it, and your square root wouldn't go away. What the hell? You did a lot of freaking work you didn't have to do, and you didn't get anywhere. That sounds like something I want to do, and some of you guys are like, that's how I feel math. So, no, that is when you do things wrong. That's what math becomes. Math is like, don't do that. Oh shit, well, go do it. So I have to isolate where my variable is stuck first. Everything we've done so far, do you see how I didn't have anything on the side? That's why Robin asked the question. She's like, I know you're going to do that. Yes, I will. So the first thing you have to do here is subtract
Rid of the one.
and then it's just like before. Now I do what to both sides?
Square.
Square both sides.
Love.
X equals 11.
Love.
Now I want to. Let me see if I can't explain this. Right here, when we were here, right there. What has to be inside the square root for the answer to be 2? What do I take the square root of to get 2? What do I take the square root of to get 2?
4.
Square root of 8 is not 2.
4.
Square root of 4 is 2.
square root.
So what does this have to be in order for this to be true? It has to be 4. Isn't that the next line? Isn't that what that says? Do you see that? So the thing you guys hated about this problem was we are forced to look at this that way. I can always look at any equation the way I just did. What do I have to replace this expression with to make it true? 4. That's what algebra does for me, but it could also just go, oh, that has to be 4 in order for this to continue. I mean, that's just the truth. Doesn't it have to be 4 in order for this to be true? So then I can write that and keep going. So what does this have to be in order for this to be true? 2 or negative 2. I write that and keep going. I'm forced to do this that way. I could do this that way for anything. Absolute values is the one thing that I'm forced to do it. Why? Because absolute values are evil. They have 2 things inside of them that we're like, oh shit. I don't know if you guys are with me or not.
I get it.
I like it. I like it. I couldn't really explain that fully until I got here. So I could show you. Okay. So this is where I say it's sort of like I'm teaching you how to be a dictator. You got a little country. You isolate your radical element and then you kill it, right? Boom. Okay. Right. So it's teaching you how to kill and be tyrants, and then you go out in the world and it's great. All right. So last kind here. You ready? Last type. This is where things get more interesting. And this is sort of like what you're asking way too early, though, with absolute values. But I could have, what about this equation here?
Is this all of chapter, or all of 10.6?
Yes.
We're finishing 10.6? Okay.
Yes. Yes.